Hello friends, in some of our previous lectures we have already started with this topic called as simplex method. Now in those previous lectures what we have seen was the basic concepts of simplex method. Then we have seen how to transform a given linear programming problem into a standard form. We have also seen something called as a degenerate and a non-degenerate solution, and then one lecture was entirely devoted just to understand how to solve a question by using the simplex method. In that lecture we have already discussed all the concepts that were needed to start with the simplex method. Now in our today's lecture we are going to start with again simplex method, but for a minimizing function. My previous lecture was simplex method for a maximizing function. This lecture I am going to discuss simplex method for a minimizing function. So students, I welcome you all to this channel Pankaj Lade. Today we are going to start with simplex method for a minimizing function. Now I hope you have already seen my previous lectures. Make sure that you have seen the previous lectures and then you will watch this particular lecture so that you won't face difficulty to understand what the concept is. So make sure that you have watched all my previous lectures. All the links for the previous lectures has been provided into the description box, so make sure you go and watch those lectures and then you come and watch this particular concept. Now let's begin with the problem. The problem is minimize z is equal to x1 minus 3x2 plus 4x3. So that's my question. The question is for minimizing. Now if you have watched my previous lecture, you will definitely come to know that the first concept that is told is the problem should be of maximizing. The very first need is the question should be of maximizing type. I can observe that the question given to me is a minimizing problem, isn't it? That means my first job is to transform the minimizing problem into a maximizing problem. So let's see how it can be done. You simply have to add a negative sign on both the sides. That means now I can write the same question like this: maximize, let us call it as z dash, or you can call it as z1. It is equal to minus of z, isn't it? Just add a negative sign to the minimizing function. So minus of z, and that would become minus of x1 and then plus 3x2 and minus of 4x3. So that's my objective function now. I have transformed the minimizing function into a maximizing function, and it can be easily done by adding a negative sign on both the sides. So z dash equal to minus of z, and I have put up a negative sign. I have changed the sign of all the terms on the right hand side. Now let's move ahead with the subjective function. So the subjective functions, the second rule was whatever right hand side is given to me for a subjective function. Now you remember that the subjective functions are also called as constraints, or they are also called as the inequalities, isn't it? Now these inequalities or the constants that I have should have their right hand side negative. It is non-negative, isn't it? One of the inequations you can observe, it contains a negative sign on the right hand side. So my rule says that whatever inequations are involved, the inequation should have the right hand side with a non-negative number. You can see there is a negative sign here. So my next challenge is to transform this negative sign into a positive sign. Again, it can be very easily done by putting a negative sign on both the sides. But now you should remember that when you put a negative sign on both the sides, the inequality sign will change. It will change from greater than equal to less than or equal to. So that's the second thing I should be doing. So I'm going to write 3x1 minus of x2 plus 2x3 less than or equal to 7. So that's my first inequation. All the inequalities should be of less than or equal to type. So we have to take care that all the inequations are always of less than or equal to type. So if you can come to the second inequation, or here I have to put up a negative sign on both the sides because right hand side was minus 12. I have to make it plus 12. So let's put a negative sign on both the sides. So I'll be getting minus of 2x1 and it becomes 4x2 with a positive sign, and again less than or equal to 12, isn't it? Now you can observe that this particular inequation can be divided with 2, isn't it? The 2 is a common multiple on both the sides. The same inequation can be written as, that is, I can say minus x1 plus 2x2 less than or equal to 6. So that's my second inequation. I have divided the second inequation with 2. So this can happen if there is a common multiple. So that's the second inequation, and no worries with the third inequation. It is also less than or equal to type. So I'm going to take the third inequation, which is minus of 4x1 plus 3x2 plus 8x3 less than or equal to 10. So these are my three inequations that I have written, and obviously the non-negativity constants, which is telling me that x1, x2, x3 are all greater than or equal to 0. So now if I take the three inequations, the next thing that I want to do to start with the simplex method is to get the standard form, isn't it? I have to transform this given linear programming problem into a standard form. So let's do it. Let's transform this inequation into a standard form. Now, you remember that we have to add something called as the slack variables here. Since all of my inequations are of less than or equal to type, so I'm going to add something called as the slack variable over there, isn't it? So let's add slack variables. Now, I can see that there are three inequations. That is why I will need three different slack variables for the three inequations. So my ultimate need is of three slack variables. These slack variables will be added to the objective function, isn't it? So I'm going to add those slack variables to the objective function also. So I'm going to get the standard form. So I'm going to write standard form here. Let's write the standard form. I can write now the objective function now becomes z dash is equal to minus of x1 plus 3x2 minus of 4x3 plus 0s1 plus 0s2 plus 0s3. Now you remember why three slack variables are added over here, and it does not matter whether I write a plus sign or a minus sign, because 0 is a neutral number. It is not going to cost us anything whether to write a positive sign or a negative sign. So there were three inequations, so three slack variables were going to come, hence I have written s1, s2 and s3, the three slack variables. Let's go to the first inequation. So now I can say one more thing I'll be doing here. I'll transfer all the terms from the right hand side to the left hand side and write the inequation as z dash plus x1 minus 3x2 plus 4x3 again plus 0s1 plus 0s2 and 0s3. Again I am telling, since 0 is a neutral number, there is no impact whether I put a positive sign or a negative sign as a coefficient of 0. So it's not going to matter us whether you put a plus or a minus sign here, but then usually you keep a positive sign for all the zeros. So that's my equation, that's my objective function, and on the right hand side I'll write equal to 0, isn't it? So that's your objective function first of all. The next thing is, let's write all the subjective functions. You want to transform them into equalities now. So subjective functions are going to become, the first inequation becomes 3x1 minus of x2 plus 2x3 plus s1 plus 0s2 plus 0s3, isn't it? And then it is going to become equal to 7. So that's my first inequation transformed into an equation. Let's go to the second inequation, which is here now, isn't it? The box that has been put up for the second inequation. So I'm going to write here minus of x1 then plus 2x2. You can observe that there is no x3 term present in the inequation. So I'm going to write plus 0x3 0s1 plus s2 plus 0s3 equal to, it was 6 here, so I'm going to write 6 on the right hand side. So that's the second inequation transformed into an equation. Let's move ahead with the third inequation. So the third inequation now gets transformed into an equation. So I'm going to write minus of 4x1 then plus 3x2, then I have plus 8x3 plus 8x3, then there is 0s1 plus 0s2 and plus s3 is equal to 10. The right hand side was 10, so I'm going to write 10 here. So all the subjective functions, all the constraints, the inequations have been transformed into equations by making use of slack variables. The last thing that you should be writing is the non-negativity constraints. So I'm going to write the non-negativity constraints. We already had three constraints, isn't it? x1, x2 and x3, they are all greater than or equal to 0, and we have added 3 slack variables, isn't it? s1, s2 and s3. So x1, x2, x3, s1, s2, s3, these all variables should be greater than or equal to 0, isn't it? So the two conditions, the 2-3 conditions that were needed to transform a given linear programming problem into the standard form is taken care of. The minimizing function has been transformed into a maximizing function. The right hand side of all the inequations, if it is negative, I will transform it into a positive. All the inequations must be of less than or equal to type. Then I have added all the slack variables and I have written the non-negativity constant. So this is what I have done with the given linear programming problem. I have transformed it into a standard form. The next step is to write the simplex table. So students, so far what we have done is we have transformed the given linear programming problem into a standard form. Now my job is to make the simplex table. Now you already know how the simplex table looks like, isn't it? We have something called as a basic variables. We have the coefficients of x1, x2, x3 and so on. Then we have something called as the right hand side of the subjective functions, and then there was a minimum ratio. Now I'm going to make the simplex table over here. The first thing that I need to know is the basic variables. Now you remember that the basic variables are those variables whose value, whose solution is usually non-zero, and the non-basic variables are those variables whose value will be always and always taken as 0. So there was a basic variable, there is a non-basic variable. Basic variables in general, the values are non-zero, whereas the non-basic variables, the value is always 0. So I'm going to start with the simplex table here. The first column that I'm going to put in the simplex table is my basic variable. So I'm going to write here basic variable. So let us write the basic variable as my first column. So basic variable is the first column. Then let's write the coefficients of x1, x2, x3, s1, s2 and s3, isn't it? So coefficient of all the decision variables and the slack variables in the subjective as well as the objective function, isn't it? So we have this objective function over here. This is our objective function, isn't it? And then we have the subjective functions. So the variables x1, x2, x3, s1, s2, s3. I'm going to write the coefficients of all the variables in the objective as well as the subjective functions over here. The next thing is the RHS of the constraints, the inequations which has been transformed into equalities, or you can say the subjective functions. So RHS of the constraints, isn't it? So we call it as XB. If you remember, it was called as XB, the right hand side of all the subjective functions. And finally we have something called as the minimum ratio. Students, all these things I have already taken in my previous lecture of simplex method. The description box, you can go and check. I have already given the link for that particular lecture. So make sure that you have watched the previous video and then you will come to this particular lecture to understand the things very clearly. So that's the last column that I will need in the simplex table. It's called the minimum ratio and is given by XB upon Xin, isn't it? So this is how the simplex table will look like. Now what we are going to do is we are going to fill up all the values which are taken from the standard form, isn't it? So let's put up all the values over here. So the very first thing I'll be writing is z dash, isn't it? Which is not a basic variable. So z dash is my optimum solution. I want to find the maximum or the minimum value of the objective function, which is called as the optimum solution. So the value of z dash is called as the optimum solution, the maximum or the minimum solution. So z dash, and what are the coefficients we have? x1 has coefficient 1, so let's write 1 here. x2 has coefficient -3, so I'm going to write -3 here. x3 has coefficient 4, so let's write 4. s1, s2, s3, everybody has a coefficient 0, so let's write 0, 0 and 0, isn't it? The next thing is the basic variables I'm going to write. So I'm going to keep this column a little bit empty at this moment because I'm yet to decide my basic variables. Let's write the coefficients of all the decision and the slack variables from the subjective function. So we have x1, the coefficient is 3, so I'm going to write 3 here, then -1, then there is 2, isn't it? You can observe the values over here. Then there is 1, 0, 0. So I am going to write 1, 0 and 0. Let's come to the second subjective function. So we have -1, then we have 2, then we have 0, then we have 0, 1, 0. So let's write 0, 1 and 0. And finally the third subjective function, we have -4, 3, 8, 0, 0 and 1, isn't it? So that is what the simplex table is going to look like. Now if you observe here, I can see a unit matrix, isn't it? 1, 0, 0, 0, 1, 0, 0, 0, 1. There is a unit matrix, and if you remember, this unit matrix was called as the basic matrix, and the variables which are corresponding to this basic matrix will be called as the basic variables. So I'm going to take the basic variables as S1, S2 and S3. Now the next three variables, x1, x2 and x3, these will be called as a non-basic variables, and the solution for the non-basic variables is always and always taken as 0. So x1, x2 and x3 will be taken equal to 0. So if you go back to your standard form, the objective function, and put the values of x1, x2 and x3 as 0, and since s1, s2, s3 are already multiplied with 0, so the ultimate answer is going to come 0, which I'm going to write here. So the value of z dash, the initial value of z dash came 0. Now this can be the maximum value or the minimum value depending on the question, isn't it? But now I have to check whether this is the optimum solution or not, and it will be told by the entire row of z dash, isn't it? The row of z dash will specify whether we have got the maximum, the optimum solution or not, the maximum or the minimum solution or not. If there is at least one entry in the row of z dash present which is negative, if there is at least one entry present in the row of z dash negative, then my friends, you have not reached at the optimum solution, isn't it? You are yet to reach the optimum solution. If all the values in the row of z dash are non-negative, if all the values of z dash, the row z dash are non-negative, then and only then you can say that you have reached at the optimum solution. So to reach at the optimum solution, to tell whether the given value is optimum or not, what is needed is all the entries in the row of z dash should be non-negative. If any of the entry is negative, then you have not reached at the optimum solution. So make sure that you watch your row of z dash very carefully. So I can observe here that z dash contains -3. That means I am yet to reach at the optimum solution. That means I have to change my basic variables, isn't it? And who will decide that who goes and what comes in? It is decided by the minimum ratio. Now one thing is left here is to write the right hand side of all the subjective functions. Let's write those right hand sides. It is 7, 6 and 10, isn't it? So I have to pick up that variable which is having the most negative value. I have to pick up the variable which is having the most negative value from the row of z dash, from the row of z dash. So I can see there is one here, positive value, so let's discard it. 4, 0, 0, let's discard these values. Only one value is present which is -3. Suppose if this was -4, this was -3, then the most negative value becomes -4. That means your x3 variable will now become the incoming vector, and if someone is going to come in, someone has to go out. So one of these three variables will go out, isn't it? So S1, S2, S3, someone will leave from here, and who will leave will be decided by the minimum ratio. What leaves is decided by the minimum ratio. So at this moment, in the given situation, -3 is the most negative value. So this is going to become my incoming vector, isn't it? This is called as the incoming vector. This is also called as the key column, isn't it? If you remember, this was also called as the key column, or we can also call it as the pivot column, isn't it? So this is the key column or the pivot column, or it is called as the incoming vector, and is denoted by x in. So from here I'm going to get the value of x in. this is the value of xb, I can definitely get something called as a minimum ratio. Now do you remember that in the minimum ratio, if you get all negative entries, then my friends, you will have something called as an unbounded solution for the given linear programming problem, isn't it? So all negative values should be ignored. All values which are going to become infinity should also be ignored. So negative values and infinity values will be completely ignored, isn't it? And if all values came negative, then your solution is unbounded. The given linear programming problem will be an unbounded solution. So make sure that you are writing down these notes in your notebook. So take a pen and a paper along with you, and make sure as the solution is proceeding, you are also noting down all the details very carefully. So let's get the minimum ratio. That is going to decide who is going to leave. We have already understood what is going to come in, isn't it? The x2 variable is now going to become the next basic variable. So it's an incoming vector. Someone has to leave now, decided by the minimum ratio. Let's get the minimum ratio. So 7 divides by -1. So 7 divides by -1 is a negative value. So I would discard this value completely from here, isn't it? Then I have 6 divided by 2, so I get 3 here, and then 10 gets divided by 3, so 10 divided by 3, my friends, it is 3.3333, isn't it? So out of these two values, which is the minimum value? Since the name is suggesting you have to get the minimum ratio, so the minimum value is 3, so that becomes my outgoing vector, isn't it? So that's your outgoing vector. That means who leaves from the simplex table? S2 will leave from the simplex table. S2 leaves from the simplex table, isn't it? And who comes in? S2 leaves, X2 will come in, isn't it? So this is what the initial simplex table will look like, isn't it? So I'm going to now proceed further to the next simplex table, which will be called as iteration 1. So that is how the first simplex table, the initial simplex table, looks like. Make sure that you have noted down the first simplex table, the initial simplex table. S2 is going to go out and X2 is going to come in. So X2 is the incoming vector, S2 is the outgoing vector. So we have finished with the initial simplex table. Now we have to proceed with the first iteration, the next simplex table. We have also decided who is the incoming vector and who is the outgoing vector. Now, do you remember that the intersection of the incoming and the outgoing vector? Now, incoming vector is also called as the key column, or I can call it as the pivot column, whereas the outgoing vector is also called as the key row or the pivot row. And the intersection of the key column and the key row is called as the key element, or it is also called as a pivot element or pivot element. Now this element is 2 over here, and my job is to make this 2 as 1, because I have already decided. Now see, S2 is going to leave and X2 is going to come in. That means my new basic variables are, so the first thing I'll be writing is Z dash, isn't it? I'm going to write Z dash at the beginning, and obviously some changes are going to happen here. Then the next variable, the basic variable, is S1. Then S2 has left, X2 has come in, and then there is S3. So I now can see that S1, X2 and S3 is the order of the basic variables. So S1 has to look 1 0 0, because the basic variables have been brought from the basic matrix, and the basic matrix is a unit matrix. The first variable is S1, the first variable is S1, so it is 1 0 0. X2 is the next one, so 0 1 0. So X2 is right now -1, 2 and 3. It has to become 0 1 and 0. That means 2 has to become 1, isn't it? So my job is going to get dividing this particular row by 2. I'm going to divide this entire row by 2. So let's do it up to 6, isn't it? Up to the XB value. I'm going to divide till the XB value. So let's divide this with 2. So I'll be getting now -1 by 2, because it was -1. Then 2 gets divided by 2, you get 1. Then 0 gets divided by 2, you get 0. Again you will be getting 0. then 1 gets divided by 2, so it becomes 1 by 2. Finally it is again 0. 6 gets divided by 2, you get 3 over here. So this is what your next row would look like, the x2 row would look like. Taking the help of this 1, elements above and below will now become 0, isn't it? That means this minus 1 has to become 0 and the 3 also has to become 0. So this is R1, isn't it? This row is called as R1. This was R2, but I'm going to write R2 here in the next table. I'm going to write R2 here, isn't it? So that is very important. So I'm going to write R2 here, and then there is R3, which is over here. So this is R3 row, and the very first row I'm going to call it as R0, isn't it? So whatever elements are present in the entire key column, whatever elements are present now, whatever elements are present here, they should all be made 0, taking the help of this 1. So let's begin with the very first row, which is R0. So what row operation I will need to write, since this is minus 3 and I want to make it 0, I have 1 over here. So I will need R0. I will need R0, which is R0, I can say. Then it is minus 3, so I write plus 3 into R2. So into R2. This is my first row transformation. So let's do it. So there is 1 here. So I write 1 plus 3 into R2, which is minus 1 by 2. So it becomes minus 3 by 2. Are you getting it? So see what do we have here? There is 1 here, isn't it? And then you are adding plus 3 into R2. R2 is minus 1 by 2, so you get 1 minus 3 by 2. So 1 minus 3 by 2, you will be getting the value as minus 1 by 2. So that's my first value. Then R0 is minus 3 plus 3 into this is 1, so minus 3 plus 3 becomes 0. So that becomes 0, isn't it? So looking at the minus 1 by 2, I am very sure now this is not my final simplex table, isn't it? Whatever value of z dash I am going to get, it is not going to be the optimum solution. To get the optimum solution, every single entry present in the row of z dash has to be non-negative. So at the beginning only I have got minus 1 by 2. From there it is very clear that whatever value I am going to get here is not going to be the optimum solution. I will have to proceed further for one more simplex table. Fine. So let's get all the other values also. So we have 4 here. R0 is 4. So let's write 4. Then plus 3 into R2 is 0 here. So I'm going to get 4. Then R0 is 0. Plus 3 into 1, plus 3 into 0. So again I get 0 only here. For S1 it was 0, isn't it? So R0 was 0. 3 into here also I get 0. So 0 plus 3 into 0 gives me 0. Again S2 is 0 here now. And then it is half. So 3 into 1 by 2. So 0 plus 3 into 1 by 2. That gives me 3 by 2. Then S3 is 0 here. Here also 0. So I'm going to get 0. And finally it is 0. XB 0. Plus 3 into R2 is 3. So 0 plus 3 into 3. That gives me 9, isn't it? So that is what the value of XB has come, but it is not the optimum solution because every entry in the row of Z dash should be non-negative. And I can see that minus 1 by 2. Because of minus 1 by 2, this solution is not the optimum solution. I have to make one more simplex table. So at this moment, let's proceed further. I have to change these values also to make them 0. So I am going to now write the new elementary row transformation. I am going to transform R1. The value is minus 1 here. So I'm simply going to write R1 plus, this is R2, isn't it? R1 plus R2. So what is R1 here? 3. R2 is minus 1 by 2. You are going to add them. So 3 minus 1 by 2. So that's 3 2s are 6 minus 1. So you get 5 by 2 here. Let's write 5 by 2. Then obviously minus 1 and plus 1 is going to give me 0. So let's write 0. Then the next one we have, here it is 2 and then it is 0. So I'm going to get 2. Isn't it? Then here it is 1 and here 0. So I'm going to get 1. Then 0 and plus half. So I'm going to get 1 by 2 here. Then 0 and 0. So I'll be getting 0. Then there is 7. See what you're doing? R1 plus R2 you're doing. So that's 7 plus 3. That will give me 10. Isn't it? So you have to be very careful with the entries over there. one slight mistake in the entry and everything goes wrong. And the problem here is you will not be able to judge where the mistake has happened. So make sure while writing all the values you are very calm. Write them very carefully, double check the values if you want, if you have to, but do not make a silly mistake. So let's proceed further. S3 now I want to start. I have C -4, so I'm going to write the new row operation. It is R3, isn't it? And I want to make this value as 0 here. This 3 has to become 0, so you have to take care which column are you considering. Isn't the key column is under consideration, so 3 has to become 0. So R3 minus 3 times of it is R2. So let's write the very first value. It's -4 here, isn't it? -3 into R2 is -1/2, so that becomes +3/2. So I'll be getting -8 plus 3. So -8 plus 3 gives me -5/2, isn't it? Then the next value obviously is going to come 0 because it was 3. Then minus of 3 into R2 became 0. Next value is 8, so I'll write 8 at the beginning, isn't it? -3 into R2 is 0, so I'll be getting 8 here. Further, next value is 0, so I'm going to write 0. R3 is 0, R2 is also 0, so I'm going to get 0 here. Let's move ahead. I have 0 in S2, so write 0. -3 into R2, which is half, so 0 minus 3/2, I get -3/2. And finally 1 minus 3 into 0, I get 1 here. And the last value, which is R3 is 10 minus 3 into R2, so it is 10 minus 3 into R2 is 2, R2 is 3, very sorry for that. So 10 minus 9, I'm going to get 1 here, isn't it? So this is how the simplex table, the second simplex table, is going to look like. Now let's get the minimum ratio. To get the minimum ratio, I need to decide the incoming vector, and the incoming vector is the most negative value in the row of Z dash. Row of Z dash, you take the most negative value. It can be very easily understood. It is X1, isn't it? So that becomes your incoming vector, isn't it? So this is our incoming vector. So that's Xn, isn't it? We already have Xb. Let's divide the values. Make sure all negative entries and infinite values are totally ignored. All negative values and values which are going to turn out to be infinity must be completely ignored. Have you also noticed the very first basic variable was S1? Look at S1. It is 1 0 0, isn't it? Next value is X2, 0 1 0. Look at the order, isn't it? 1 0 0 0 1 0. And now you can definitely guess that S3 is looking like 0 0 1. It has to look like 0 0 1. So take a look at this. That's the basic matrix. The first was S1 1 0 0, X2 0 1 0, and S3 0 0 1. So that is how you can understand what a basic variable is, isn't it? One who forms the basic matrix is called as a basic variable, and if the basic variable is there, it will definitely make the basic matrix. Let's get the minimum ratio. Now I have decided that this is my incoming vector, isn't it? This is our incoming vector. This is our incoming vector, isn't it? So this incoming vector, I'm going to take and get the value of minimum ratio. So I do xb upon xn. So I get 10 upon 5/2. So if I do 10 upon 5/2, so 2 goes up, 5 and 10 cancels, you get 4 over here, isn't it? So 2 goes up, 5 and 10 has cancelled, you get 4, the first value. The next value is xb is 3 divided by -1/2. So you can observe 3 gets divided with a negative value. This is definitely ignored, isn't it? So I'm going to ignore that particular term. The next is 1 divided by -5/2. Again, you can very clearly understand that this value is also to be ignored. The negative values in minimum ratio and infinite values in the minimum ratio should be completely ignored. And now from whatever left values are there, you have to take the minimum values. There is only one value present now, that is 4. So it is a very obvious choice that 4 becomes S1 becomes your outgoing vector. So I'm going to block this row. This is my outgoing vector, isn't it? So S1 becomes the outgoing vector. So who leaves from here? S1 leaves, isn't it? S1 leaves, and who comes in? X1 comes in. So S1 leaves and X1 comes in. So that is how you get your incoming and the outgoing vector. And this 5 by 2 will be called as what? It is an intersection of the incoming and the outgoing vector. So that is going to be the pivot element or the pivot element we say, isn't it? And my job is to make this pivot element equal to 1 in my next simplex table. So I have to proceed further for getting one more simplex table, isn't it? I'll be getting one more simplex table. Make sure that you have noted down the second simplex table also very properly in your notebooks. So students, so far we have seen the second simplex table, isn't it? Now we have to go to the third simplex table. Now in the second simplex table we have already notified our incoming and the outgoing vectors, and their intersection is going to be the pivot element, isn't it? So that's 5 by 2. Now my job is to change this 5 by 2 into 1, isn't it? So 5 by 2 has to change to 1. The other thing I should take care is S1 is going to leave, isn't it? And in place of S1, who's the next variable that is going to come? It is X1. So I'll write here. So there is Z dash at the beginning I have written, isn't it? Obviously some changes are going to happen here. The next basic variable is going to be S1 goes, X1 comes in. So X1 becomes my first basic variable. So X1 should look like what? It should look like 1 0 0, isn't it? This prediction you can now do. So S1 has gone, X1 has come in. So X1 is the very first basic variable. It has to look 1 0 0 here. Next one is obviously X2, and the last one is S3, isn't it? So my job is to make this element as 1 first of all. So let's make S1 as 1. It can be easily done by multiplying this entire row by 2 upon 5. So there is 5 by 2. I have to make it 1. I will multiply it with 2 by 5. So let's multiply this entire row with 2 upon 5. So when I multiply this with 2 upon 5, the first value I'll be getting is 1, isn't it? That becomes 1. 0 multiplies with 2 by 5, you get 0. Multiply with 2 upon 5, isn't it? So 2 upon 5, you get 4 upon 5. Again, next value is 1. It gets multiplied with 2 upon 5. So I'm going to get 2 by 5 here. The next value is 1 by 2. It is getting multiplied with 2 upon 5. So 2 cancels. You get 1 upon 5. And then S3 multiplies with 2 by 5, so that's 0 here. And then there is 10. It multiplies with 2 upon 5. So 10 and 5 cancels. You get 4 over here, isn't it? That's 2 upon 5. So 5 and 10 cancels. You get 2. 2 into 2 becomes 4. So that is how your first row X1 has changed, isn't it? So that's X1. Now let's move ahead and make the other elements as 0. So now this is R0, if you remember, isn't it? Z dash is called as R0. This was R1, so I'm going to write R1 here. The changed row, isn't it? That is going to be called as R1. So don't go to R1 here. R1 is here. Then this is your R2 and R3. So all other elements of the key column, should now become 0. So your first job is to make this minus 1 by 2 as 0. You have 1, you want to make minus 1 by 2 as 0. So that's R0. I'm going to write here then. Let's write it here. I have R0, which is minus 1 by 2 plus 1 by 2 into R1, isn't it? So let's write here R1. So that's minus 1 by 2 R0 value plus 1 into 1 by 2. So this value is going to become 0. You have to be very careful while doing this row operations, isn't it? You know the concepts of matrices. Use those concepts of matrices to get the answers over here. So be very calm while doing these questions. Let's move ahead. Next value is 0. Isn't it? Here also I see 0. So 0 plus half into 0. It is going to stay 0. Then there is 4. So there is 4. R0 is 4 plus 1 by 2 into R1 is 4 upon 5. You write 4 upon 5. So 2 and 4 cancels. You get to 2 by 5. So 5 4s are it's 20 plus 2. 22 upon 5. So I write 22 upon 5 here. Let's move ahead with the next value. There is 0 here and then 2 by 5. So I write 0 plus half into. That's 2 by 5. 2 by 5, so 2 cancels, you get 1 by 5. So I'm going to write 1 by 5 here. Are you observing all the values are staying positive, or 0, isn't it? They are all non-negative values. That means now I can be very sure that the value that I'm going to get is going to be the optimum solution, isn't it? I'm going to get the optimum solution because so far all the entries of the row Z dash are either 0 or they are positive. That means they are all non-negative. So whenever they are non-negative, that means I am going to reach for the optimum solution at this moment. So let's proceed further, students. Next value is 3 by 2, isn't it? So I'm going to write 3 by 2 here. R0 is 3 by 2 plus 1 by 2 into R1 is how much? 1 by 5. So write 1 by 5. That becomes 3 by 2 plus 1 by 10. You can multiply by 5 here. So that becomes 15 by 10 plus 1 by 10. So 15 by 10 plus 1 by 10. That's 16 upon 10. 16 upon 10 can be written as 2, 8s and 2, 5s are, so I'm going to 8 upon 5 here, still positive value, isn't it? Last one is S3, 0, and here also 0, so you will be getting 0. So that was my first row operation to transform Z dash. Let's get XB also. So XB, the row operation that I have written was R0, which was minus half, and then plus 1 upon 2 into R1. So let's do the last value also here. So R0 is 9, isn't it? So I'm going to write 9 plus 1 by 2 into R1 is 4. So I write 4 here. So 2 and 4 cancel. So you get 2. 9 plus 2 is 11. So be very sure that the value that I've reached now is going to be the optimum solution. Why it is optimum solution? Because all the entries of the row Z dash are non-negative. All entries of the row Z dash are coming non-negative. That means I can be very sure that the optimum solution has been reached, isn't it? The value that I've got here, the 11 value, is definitely going to be the optimum solution. So this is what I have reached at the optimum solution. And how did I came to this particular result? This particular result has been derived by looking at the row of Z dash. Every value there is what? It is non-negative. But as I see, I have to proceed further. I have to complete my table over here. So let's very quickly complete the table. Now, in the exam, if it happens that you don't have enough time to complete this particular solution, you have already got the value 11 here. You have understood that all the values here are non-negative. That means the value that have come for Z dash is definitely a optimum solution. So it's not my recommendation, but if the time does not permit, you can leave your table here because we have reached our optimum solution. My job is to get the value of optimum solution. Now the problem that will be arising is to get the values of x1 and x2. Now x1 is definitely going to be 4, isn't it? X1 is going to be 4. I have to tell for what decision variables, for what values of the decision variables this Z dash has become 11, isn't it? So x1 is going to be 4, but I still want to get x2 value, and since I can see x3 has not entered into the table, the value of x3 is by default going to be 0. So x3 is going to be 0. So I need to find the value of x2. For that I have to proceed with the entire table. So let's move ahead. The next one is minus half here, isn't it? I have to make it 0. So I'll be writing the row operation as R2, which is minus half, R2 plus half into R1 is here. So I write R1, so this is definitely going to be 0. Now you can now cross check that since x1 is your first variable, the first basic variable, its value is definitely going to be 1, 0 and 0. So I can write it blindly now, 1, 0, 0. Next is x2. 0, 1, 0. There is no need to calculate them, isn't it? We can now start saving time. This is what you got to learn. How can you save time? This concept can be used in the previous table, also, because basic variables are going to definitely comprise the basic matrix, isn't it? So basic variables will make the basic matrix. That means definitely x1 is going to look like 1, 0, 0 because it is the very first variable. Second is x2, it is going to look like 0, 1, 0. Next is s3, it is definitely going to look like 0, 0 and 1. So some time can be saved, isn't it? Some of the values are already obtained. You can directly write these values. Now I need to just focus on these 6 values, isn't it? So that is how the table can be made in a quicker way, isn't it? You can make it quickly. Let's move ahead. Let's take this value now. So this is x2 and x3, so it is 0 here. So I'm going to get 0 plus half into 4 upon 5, isn't it? 0 plus half into, there is 4 upon 5 here, so I'll write 4 upon 5. So 2 and 4 cancels, you get 2 by 5. So I'm going to write 2 by 5 here. Let's move ahead. The next value is also 0, 0 here, plus 1 by 2 into 2 by 5. So 1 by 2 and 2 by 5, 2 cancels, 1 by 5. That's my value here, 1 by 5. Let's move ahead, get the next value also. Now, these values are also not needed, isn't it? You just need the value of x2. You can directly go here and get the value of x2. Directly you can get the value of x2. No need to get the intermediate values. They are not going to tell us anything. So it depends on you whether you want to complete the final simplex table or not. If it would have been a case for me, I would definitely leave the table as it is. I will not get the entries because I have got my optimum solution. I will be getting these entries from here, x1, x2 and s3. s3 is not going to be taken into account because it is multiplied with 0. So x1 is there, x2 is there. Since x3 has not entered, its value is going to be taken as 0. So I have got my solution. There is no need to find this entire simplex table anymore, isn't it? But we will definitely do it so that we get a good amount of practice. We do not make any mistakes, silly mistakes while doing some calculations. So that's why we are going to complete this table also. So let's move ahead with the next value. We have 1 upon 2 here. So let's write 1 upon 2 here. That's 1 upon 2, isn't it? 1 upon 2 and then plus 1 by 2 into, the value is 1 by 5. 1 by 5, so I will multiply and divide by 5, so that's 10, 5 plus 1, 6 by 10 you get, 6 by 10 is 3 by 5, so I'm going to write 3 by 5. Students, this is up to you, whatever simple way you can get for yourself. You just do the calculations that way, isn't it? So there is no need for me to explain you how the calculations are coming. You are already smart enough to understand all the calculations. So finally it was 0, so no need to get that value. Let's come to the last row. So what do I have here now? I need to make this minus 5 by 2 as 0. So that's R3 plus 5 by 2 into R1, isn't it? It was 1 here. So let's do the calculation. It was 0, 0, so I need to take the value of 8. So R3 is 8 plus 5 upon 2 into R1 is 4 upon 5. 4 upon 5, so that's 5 cancels, then 2, you get 10 here. So I'll write 10. The next value is 0 here, 0, and then 5 by 2 and 2 by 5, so that's 1, so I'm going to write 1 here. Next value is minus 3 by 2, so let's write minus 3 by 2 from here, isn't it? Minus 3 by 2 and then plus 5 by 2 into R1 is 1 by 5, so that 1 by 5, 5 and 5 cancels, you get minus 3 by 2 plus 1 by 2, that's minus 2 by 2, that will give me minus 1, so I'm least concerned what values have come here, isn't it? Then I have to get this value, so x2 that was left, let's write that value also. Okay, first I'll complete this value here. So we had 1 plus 5 by 2 into R1 is 4, so that's 2 and 2 cancels, 5 to 10 plus 1 you get 11 here, and I will get one more value that was left for x2, isn't it? So we had minus 1 by 2 here, that means it was R2 plus 1 by 2 times of R1, so R2 is 3 plus 1 by 2 times of 4, so that cancels 2, 3 plus 2, it is going to be 5, isn't it? So that means now there is no need to get the minimum ratio. You have all understood, isn't it? No need to get the minimum ratio. You have come to the optimum solution. So what I'll do is I'll remove the previous table. Now there is no need of the previous table. So I'm going to remove the previous table from here and I'm going to write the final solution, isn't it? I'm going to write the final solution. So students, the final solution is going to be, we have z dash has come 11, isn't it? Z dash has come 11. x1 we have got, all the entries will be obtained from xb column. x1 we have got 4, x2 we have got 5. Since there is no entry of x3, it is going to be 0. Now this table has been obtained for maximizing type, isn't it? You want to get the minimizing type. Do you recall that z dash was equal to minus of z? That means I can write z is equal to minus of z dash, that becomes minus 11. So this is your optimum solution. You are solving this problem for minimizing type, isn't it? So that's your optimum solution. So I can say that minimum value of the objective function, is minus 11, and it has obtained for x1 is equal to 4, x2 is equal to 5 and x3 is equal to 0. Now if you want, you can go and cross check your objective function. Go and observe the objective function and put up these values 4, 5 and 0. I will challenge you that definitely you will get the answer as minus 11. You will get the minimum solution as minus 11. So students, this is how a problem on minimizing can be solved, isn't it? I hope you have understood the entire solution very properly, very thoroughly. Now what I want you is to make sure that you do practice of such kind of questions, as much as problems as you can practice to master this simplex table. Now I'll be taking one more lecture, one more session to understand some typical type of questions. Obviously in that particular lecture I will not be solving the simplex table. I'll just take some typical examples which are slightly different from this particular questions. Now you already know how to get the simplex table. What your job will be is to understand those typical questions and then get the solution for those particular questions. So students, I'm going to leave you here. I thank you for watching this video. Make sure that you also share this video, like the video. Thank you so much for watching. Have a great day ahead.